Good morning, guys. It's Naveen joining the call. Can you guys see me? Could you please check in the chat window? Great. Thank you, Rahul. Sharing the screen. Give me one moment. And let's see. Close this one. One moment, please. Sorry about that. Okay. Okay, guys. So let's see. Come back here. Okay, so just a quick and friendly review, guys. Sorry about yesterday. Not yesterday, day before yesterday, guys. I had a client visit, so I couldn't take a call. And yesterday it looked like you guys had some things going on, so we couldn't get down to the calls. So just an FYI. And let's get started, guys. We'll have a quick review of the Kubernetes today. We'll cover a little bit about the Kubernetes logging, and I also plan to give you a quick introduction of the Google Cloud also. So that is going to be the plan, guys. Okay. With that, before I bring this up, let me come back here. So, slide it. Save file. Continue. Say cloud. Code deploy. I think it is this one. Okay, so Rahul, I'll bother you a little bit today, buddy. You take a few questions and things like that. Can you come online?
Yes.
Thank you, buddy. Appreciate that. So Rahul, what do you think is the difference between Kubernetes and Docker?
Kubernetes is the container orchestration tool. Like it is used to manage a large amount of container, and Docker is for it is a container engine. It is used to create and run the container.
Good answer. Short answer. Docker is for creating containers, and Kubernetes is for orchestrating the containers. Okay.
Yes.
Let's see what we have here. As simple as that. And then we looked at okay. What are the components? What is the architecture of Kubernetes?
It is there is a client and server kind of, like there is a worker node and there is one master node, controller node. So controller node manages those worker nodes.
Good answer. So short and sweet, masterwork architecture, a pretty popular pattern that we find across multiple architectures and things like that. As simple as that. And the master is called as control plane. And let's see, what do you think is a pod in Kubernetes?
Pod is the smallest unit in the Kubernetes, and it kind of represents the container inside the Kubernetes. But it is abstraction to the container. It can contain multiple containers inside.
Okay, very good answer. In other words, short and sweet, pod is a wrapper around a container, and Kubernetes works with the pod is what you can think of. By any chance, do you remember what is the difference between pod and a deployment object?
Deployment object, in deployment we can deploy multiple pods.
The hint is on the screen.
We are seeing only this log backend for streaming to multiple log backend PPT. The second PPT is not visible.
You're not seeing the deployment update of container?
No.
Oh, sorry about that. Okay. Okay. Can you take a quick guess? What is deployment?
Deployment is we can deploy multiple pods at one time, and we can scale also, scale upgrade.
Okay, good answer. More precisely, deployment is something which will contain a replica set. Replica set is something which will contain multiple pods, as simple as that. So deployment is acting like another wrapper of replica set, which is acting like a wrapper for the pods. Okay.
Yeah.
What is the main advantage of service?
Service, we can make the IPs of the pod static, so it won't change if the pods get destroyed or we kill or recreate it.
Very good answer. In other words, more precisely, the service, the IP address of the service can remain the same, while the pods and the containers may get a new IP address for whenever they go down and they are brought back up again.
Yes,
so
and we can also use for the load balancing purpose.
Very good. Okay, and okay, that was my next question. And let's see. Okay, what do you think is EKS?
EKS is the managed Kubernetes service provided by the AWS. It is managed by AWS control plane. And
what is the main advantage of it?
We don't have to manage that control plane like a controller and its component, different components like its CD database and there are multiple.
Very good. As simple as that. We don't have to maintain it. The AWS is going to maintain it, and we can focus more on the business side of the things. Okay. And let's see. What do you think is kubectl?
kubectl is a command line utility which is used for used to run multiple. We used to perform different type of activities with the Kubernetes.
It's just a CLI tool for the Kubernetes, as simple as that. Okay. Okay. I think that should be it. Harmonic case, we have not yet done that. Let's see, I'm somewhere over here. Come back here. Okay, while I'm just bringing this up, Rahul, can you just log into the Amazon console, please?
Yes.
Pod limit. Instance type and pod limit. Here we go. What do you think is the meaning of manifest file, Rahul? Rahul, what do you think is the meaning of the manifest file?
I don't remember.
It's just the YAML file.
Okay.
Okay, can you explain me what is the difference between the green and the pink sections here?
Green section is here in the green section in selector. We are specifying what is the which pod it should get attached, and in the pink section we are specifying the type of service like load balancer or node port or something. And here inside the deployment, this green section is giving tags like labels and all.
Good answer. So in other words, more precisely, what we are bringing up in the pod or the container is the Nginx application. That could be any application. That could be a .NET, Java, or a PHP application. We are bringing up in the pod, and the name of it we are giving as front end, as simple as that. The load balancer is going to act as, as the name suggests, it is a load balancer. It is going to distribute the requests equally among multiple pods through the services and things like that. So the front end is just acting like Lego.
Yes.
Okay, what do you think is replicas here? On the left hand side.
Replicas, yeah, it will create two replicas, and if of the same pod, and if we destroy any one of the pod, it will recreate that replica.
Simple
to
as
maintain. Yeah.
Okay, good. So let's say I'm gonna pause this one here. Go here. So 16. This one. C2 console. Balances service. Okay. So I think first I will go over something, and then I'll ask you to perform a couple of exercises, Rahul. Let me see if I can. Okay. Port and first one. So declarative versus imperative. Port limit. Okay, I guess that is also an exercise directly. I may ask you to share your screen, Rahul. I think I don't have any theory. I will directly get onto the exercise.
Okay.
Let's see. Stop the share. Okay, can you share your screen, please? Rahul, by any chance, do you guys have the Google Cloud access also on the Google Cloud? Just like, do we have a login on the Google Cloud?
No, sir, we don't have. We have only for this AWS, Azure, and for OpenStack.
Oh, okay. Sounds good. Are you sharing the screen?
I had shared my screen. Is it visible?
Oh, there you go. Okay. I see it now. Sorry about that. Okay. And can you also check and see if I have in the G drive, I have uploaded the Nginx with rolling.yaml file.
Should I first deploy that EKS cluster?
EKS cluster, good idea, but let me see. I have 2 or 3 scenarios. We'll give it a few minutes or a few seconds before we go there.
Okay.
I understand why you say that, but a few more things we'll do before that one. Okay.
Okay.
And look for a with rolling.yaml. Scroll down, please.
How much file?
Oh, I think we created the file and then I think we destroyed the file, isn't it? Okay, never mind.
Yeah, I have. Are you talking about this one? This YAML, which we have used last time to create the forms.
Exactly, yeah. So scroll down cube. Okay, can you quickly tell me what is happening when we say kubectl apply ng rolling.yaml? What is that command doing?
Yeah, it is deploying this deployment, and with the creates 3 pods which are replicas of each other, and it will deploy this Nginx container with version 1.1.16.
Good answer. So more precisely, what we're doing is we're deploying the infrastructure by using this configuration. This configuration file is acting like our code. And when we say IaaS, infrastructure as services, infrastructure as code, kind of it is also the configuration itself is acting like the code. Understand?
Yes. Sir, can we, do we have any UI version of this, like, or we always need to use this configuration file?
Most of the times,
like
most of the times in production, you'll be using the command line, but we do have a kubectl, Kubernetes dashboard also. We'll probably touch that today. Okay.
Okay.
Okay, as simple as that. So I think we have already executed this ng rolling. Do you remember, or were we executing this from?
Yes, we have created this deployment last time.
Okay, create cluster. So let's see. Do one thing, Rahul. Go ahead and copy the create cluster command and try to execute that into one of the terminals. Back in.
Yeah, are you telling this this command?
Yes.
Actually, we don't have any cluster right now.
So yeah, that's why create it is what I'm saying.
Yeah. Okay.
I think there is something called a master 2. If you recall, you can SSH into the master 2, and you don't need to curl EKSCTL. Yeah, go into EC2. Look for a server called master 2. Master 1 worker.
Master 1 worker 1 worker 2 and worker. Maybe this one we have done with Cube Adam.
Like you're logged into another one. Acha, okay. Okay. You're using a different account. Okay. Never mind. Yeah, go ahead, and I think we do need a medium. So go ahead and get into master 1. I think we may have it here. EKSCTL and kubectl. I remember.
Okay. You are saying that we should log into that server which we have used last time for creating this cluster.
True.
Okay, this one was the EK server.
Okay. Please log into that one. It's t2.micro, right? Yeah, that's okay. Go ahead. Sorry about that.
Yeah.
Connect to it and try to see, just verify EKSCTL and kubectl are there.
Yes.
Okay.
Yeah.
Say, just do EKSCTL clusters get all. Get all. EKSCTL clusters. Or EKSCTL get all. EKSCTL get cluster. Sorry, get cluster. Clusters found, okay. Yeah, go ahead and create a cluster, please. And let me see while we're covering that one. Is the load balancer. So we come here. Okay. Just to keep our time productive, give me one moment here. Let me cover some theory. Wait. Manage routes, no group update. Okay, I'm going to share my screen here.
I got some errors. Just create cluster. Showing some error validation.
So scroll up a little bit, please. Pull back in progress while waiting for cloud formation. Stack, EKS CTL, EKS test cluster. Roll back in progress. Scroll down, please. And route table, pivot, route table. Scroll down, please. Source creation cancel. Yes, test because US East 1. Target.
It's telling that clean up the resources, then
if you look on top of it, what it is saying is resource resource handler return message cannot create cluster EKS test because US East 1, the targeted availability zone does not currently have sufficient capacity to support the cluster. So just choose another availability zone. So if you bring up the same command and bring up the same command, we used EKS test. I think by default it is using East 1, I think. We just need to give it a different zone.
We need to do maybe that AWS configure, in that we need to specify.
There should be a switch or an option. Let's say to specify the zone here. Bring up the command, please. Just do an up arrow.
Okay.
That's okay. That's okay. One moment. So create cluster, just like name, it should allow us to give us a zone here, is my thinking. Can you just copy that command in the chat window? Aniket, okay. I'll share it with you, Aniket. Okay, one moment. Copy this one. Come here. cluster region. Name hyphen region. That is what you need to give. Let's see. You can add maybe somewhere after the name EK test, give hyphen region and EK test space hyphen region. I think by default we are using East 1 or something like that. Just verify that. Back to terminal.
Yeah, it's using ES.
Maybe you can use East 2 or maybe, yeah, just use East 2.
Yeah. East.
Okay. I think it is because we are using the free servers, the T3 micro we're getting it generally when we're using slightly in a higher scale, we don't really get this thing, I think.
Okay.
Okay, let's see. While that is coming up, let me come back here. And city complement. I try to explain this on this. It's just slightly deep here. You keep an eye on that one while I cover a few slides from my side.
Okay.
Thank you. Okay. So EC2 instance type and pod limit. Pod limit is nothing but the number of replicas and things like that. Maximum number of allowed pods depends on the EC2 instance. So in other words, more precisely, for T3.micro or most of the free tiers, they have a limit of 3 to 4, which are used for POCs, demos, and things like that. But if you go into slightly higher scale of servers, we will have more pods that we can bring up. In other words, there are a number of replicas. Even though we say I want 10 replicas, it will not really create 10 replicas in free tier. It will only create maybe 2 or maybe 3, and the rest of them, it will not really create them. It will just have them in a different status is what it really means. Bigger the instance type, more the pods. In other words, as we increase the scale of the server, we will see that most of the time we can create multiple pods. That is what we'll try to look today. And K8 version, Kubernetes version needs to be updated. So here is a scenario. Deploying the security patches, EC2 AMI needs to be updated. So in other words, we have one master and 3 workers and 2 pods in each of the worker is what we are observing. And let's say Kubernetes version needs to be applied, or maybe some kind of patch needs to be applied is what we are saying. We need to create the AMIs. Ideally, what we need to do is we need to bring down our application. When we bring down our node or server, the pods go down. And we have to bring up another node and we have to manually bring up the the couple of pods that are running is what generally the process is. That is what we are saying as the regular update or regular way of updating. But in a managed node groups is nothing but a group of nodes which can be exposed in the internet. So ideally, manage means again AWS is taking care of, short and sweet, all this stuff. They create and they manage the workers for you. Amazon releases the AMIs, bug fix, patches, any kind of additional security related things Amazon is taking care. So EKS worker node, so bring your own custom AMI. We can also use our own custom AMIs in certain scenarios, but I think we generally go with the AMI provided by the Amazon. Automated deployment of updated AMIs with security patches, CVs. In other words, the EKS or the Amazon guys are managing in such a way that there is no downtime, application downtime. There is no additional overhead, either from billing perspective or any other perspective. Also, we don't have to incur additional costs. And auto scaling is still working as the as a upgrade is going on is what we are trying to convey here. Worker nodes version updated with one-click API. So again, in a managed scenario, the worker nodes also, the worker nodes, whether it's master worker is being taken care of by the AWS. AWS provides AMI with security updates, no patching or rehydrate effort for you. So in other words, we don't manually bring them up is what that really refers to. And okay, so here is scenario. So in other words, ideally on the left-hand side, we have v version.1.14. Whether that's a Kubernetes version or maybe an application, Nginx application, where we are using 1.14. Ideally, what we are trying to convey here is the pods are gone and then the node is removed, and automatically the new node and the upgraded version of 1.15 is being applied. So application will be up and running. AWS is orchestrating the high availability through the scaling group, and it respects the pod disruption budget. In other words, removing the pods, the containers, and again bringing up the pods and the containers is automatically handled and taken, and we are not really incurring a lot of cost. Is something to be kept in mind. So that is an advantage. So again, there is the version 1.15. That is what we are trying to do. And back to you, Rahul.
Yes.
So come back here. Have we talked about declarative and imperative scenario, Rahul? Do you by any chance recall?
Awesome.
So load balancer, and I need to. Okay. Close this one. I'm going to upload a couple of files to the G drive. Then you can download them, please. And
Okay.
Ankit, I'm going to give you access also. Back here. Close this one. Ankit, could you please check? I have added you the access. You should get an email. So yeah. And files. File. This is the load balancer.service. In the meantime, just you can download this file, load balancer, and so click on OK. Back to load balancer. Let's see what else I can do to keep our time productive. Okay, so while that is coming up, what I will do just to keep our time productive, I will get started with a little bit of the Google Cloud Computing. Will cover a few topics and things like that, so that we can save some time. Some of the topics may be familiar, but for the sake of the Google Cloud, we'll go ahead and get started with them. Okay.
Okay.
Thank you. Say come here. Say cloud. Okay. Thank you. So sharing the screen now. Okay. So a little bit of theory, some of the topics we're already covered, but we'll go over these things real quick just to keep our time productive while the clusters are coming up, guys. I think we'll try to bring up 2 or 3 case clusters today, if time permits. During those times, I will cover some of the slides of theoretical stuff of the Google Cloud. So just bear with me. So cloud computing, short and sweet. I will not go too much into detail. It is the ability to harness the power of computing on the internet, which we are already doing. We are trying to use a lot of computing and storage power on the internet via a browser, and we're doing almost everything using a browser. That's what the console is enabling. And behind the scenes, that is being powered by the cloud computing is one way to think of it. It's over the internet, it's easily available. So in other words, we're doing everything with just a browser, as simple as that. That is what we mean by easily available. It allows you to use a variety of resources, little or no initial investment. In other words, we can we will look at this scenario a little bit deep in the coming up slides, but more precisely, when new companies are getting started, they don't have to buy a lot of hardware or software, and the cloud will provide everything. So in other words, they're not investing too much in hardware or software, and as a result of that, their costs are low, their costs are much, and cloud computing is enabling that. It is flexible, use whenever you want, you can use it on anywhere in the world, we are able to access the cloud. That is one of the main advantages of the cloud computing, guys, okay? And let's see, okay, so what is the cloud? Again, ideally, to host an application on a set of servers, ideally we need physical servers, we need storage, we need to invest in networking and data center. We need to take care of the security, cooling, ongoing maintenance. This is slightly from a network and an infrastructure standpoint. These are all some of the things that we need to take care of. And the problem is that involves a lot of money. In other words, a good amount of money, especially for the small companies, it becomes a lot of money because they are small and things like that. They may not have that budget. So cloud platform makes things simpler. We have the ability to create a virtual server on the internet, which is what we are doing. We're creating multiple servers, multiple virtual machines and things like that. Virtual machines are themselves acting like the servers. We don't need to manage the aspects of such as the physical server, networking, cooling, physical security, and so on. In other words, when we are creating these servers which are managed by the AWS and things like that, they are creating the servers, they're taking care of the networking, cooling, physical security, and other things, guys, okay? We don't need to make an initial investment also. So we did not make any investment. We can just rent them ideally and we pay for what we use. That is, again, these are all the small things they may look like, but they're big advantages for many of the companies around the world is what it is. Rahul, if you find anything slightly difficult out of, just let me know. I'll try to explain that. Otherwise, I'll go a little bit fast here. Just okay. To keep it going. And when the cluster is up, just let me know so that we can switch back to it and continue. It might be a little bit confusing because I'm going to switch from cloud computing into that one. But most of the times these concepts are slightly familiar, so it should not be too complex. But if
yes, we know these basics of the cloud.
Good one. Okay. So again, infrastructure features. So for sake of discipline, the Google Cloud and things like that, let me clarify a few things just in case and things like that, Rahul, okay? Infrastructure features ability to distribute resources across regions. So cloud contains multiple regions, the region contains multiple zones, and these are all across different parts of the world. The ability of the architecture by using services such as load balancer, traffic manager. So in other words, we are getting high availability. Internally, the load balancing traffic managers are the components which are taking care of them. Add scalability to your architecture. by using services such as virtual machine scale sets. So again, that is nothing but you're scaling based on the horizontal or the vertical needs. We can also set up the configurations such that the scaling can be done. Add disaster recovery by using backup and recovery services. So all these things are provided by the cloud, short and sweet. The disaster recovery, we don't need to worry about. Making the backups manually, automating them, all that stuff can be handled by the cloud is what it means. Different kinds of cloud. Pardon me. Public cloud, private cloud, and hybrid cloud. In public, examples are cloud providers such as Microsoft Azure, Google Cloud, Amazon AWS. All of them provide the public cloud. Here, the physical infrastructure is managed by the Microsoft or the cloud provider, to be more precise. We have to access the various services offered by the cloud provider, and we can access the services via web browser. Lower cost, less maintenance, high availability and reliability. So in other words, we'll try to look at an example. Ideally, we'll take a server and we'll try to install the components and things like that. Components and software, different kinds of software in a public cloud. And we'll try to understand that. As private cloud, one of the, again, another more popular scenario. The physical infrastructure is managed by the company. This is where the company wants to own the entire infrastructure. So in public, we don't own the infrastructure. In private, we own the infrastructure and we want to tune it and configure it. Government agency or a financial institution where there's a lot of confidential data, generally they don't want the infrastructures to be given to the outside control. So that is where they can use a private cloud for themselves. But we would need to invest in the infrastructure. In other words, it's more expensive than the public cloud. Hybrid cloud is a combination of both of them. We are combining both the scenarios. We connect the on-premise infrastructure to the cloud provider. We try to get best from the both sides. In other words, we have to architect our applications and our network in such a way that we are getting the best of both sides. If we cannot migrate our current workloads to the cloud, then we keep them private. Whatever can be done publicly. So there might be some data which is confidential. That kind of data can be kept on the private cloud, and data which is not confidential or the computing part of it can be migrated to the public cloud to keep the cost lower. Generally, that is what is done, guys. Okay. So the storage is generally in the private cloud. The computing can be done in a public cloud on a pay-as-you-go basis. This also involves the additional cost because of the additional servers that we will be owning as part of the private cloud. It's acting like a combination of the private and the public, guys. Okay. Infrastructure as service, the physical servers is managed by the cloud provider. So they're giving us the infrastructure, and we don't need to manage the various aspects of the physical server. So they give us the server. We only manage the virtual server. So in other words, the physical server can have multiple virtual machines, and it is acting like a server only with all the specs and the configuration that we need. It allows you to quickly provision environments and also terminate the environments when they are not required. In other words, we can quickly bring up as many VMs or other kinds of images that we have that are available, and for different kinds of environments, guys. Again, if you find anything, I'm going a little quick and fast here. If you find anything difficult, please let me know. Infrastructure as service, no capital expenditure. So we don't have to buy the physical server, we pay for the virtual machines. It reduces the expenses. We can focus more on what's important for our business. So we might be an e-commerce application or an e-commerce company. We don't focus on the expertise of the physical servers. We focus more on how to run the business. We can get access to various computing types, which is various combinations of computing power and the storage power. We can host various types of workloads on the virtual machines. Again, we can configure it based on our requirements and specifications. We can configure the virtual machines, the storage, the computing, and other components of the virtual machines. Platform as
sir, cluster is ready.
Okay, sorry about that. Go ahead. Okay. Just do a history on this one. I think we can just look some of the basic commands and things like that we have run. We'll just execute them just to have an idea about them. So I think you can say cluster get all, what we did, describe pods, the get pods and things like that. Quickly run a few of them so that we are just quickly, I think we're using kubectl here. Start with kubectl get all, get rs, get pods, describe. Those are some things you may want to quickly run. You can say exclamation 34. This kubectl get all. So that is giving us a service. Okay, we don't have any pods and things. Just do a get pods. Okay, that's okay. It is a no result sense. If you don't have replica sets, obviously you wouldn't have any pods or deployments, is what it is. And okay, let me come back here. Load balancer. So now what we'll do is EKSCTL get cluster, please. Make sure the cluster is up. Hi. What's that? What did we do? Didn't you create a cluster just now? You so I think you're pointing to US East one, right? I think you gave it another region. Okay. Pardon me. Okay, good. Now do the get service get pods, kubectl get all. That should be good. One service only, nothing else is there. Get all shows everything. So what we'll do is go ahead and do kubectl apply. Sorry, download that load balancer.yaml file that I just uploaded onto the Google G Drive. And you can open it first. Okay, if you look at this, we have one service. We are calling it as LB service. That's like load balancer service. Under the spec, there is something called type. If you notice, that is where we are specifically saying it's a load balancer. So it is used for distributing the requests equally among multiple servers. Port is 80 by default. We use the 80 port. And the API version, front-end development, deployment is the name. Front-end
Hello, sir. You are not audible.
Rahul, I'm back, buddy. If you're there.
Yes, sir.
Okay, great. Thank you. Sorry about that. Okay, so let's see. Could you scroll down a little bit on this one, Rahul?
Yeah.
Front-end container. So what do you think is happening? And what do you think is this YAML file doing, Rahul?
This YAML file first creating this service load balancer, and then it is creating this deployment, which contain two pods replica, and it will deploy this Nginx image.
Got it. Very good. So in other words, that's like a high-level architecture or the high-level design is what the YAML file is doing, and I think you nailed it down. So let's go ahead and apply it, please.
Okay.
kubectl apply -f.
Maybe we need to create that first.
Oh yeah. You send me the history. Is this the history that you sent on this node, Rahul?
History is here.
That you shared with me? Is it this one only, or is it some other server?
It is this server which we are using previously.
Okay, it is this one only you said shared. Huh?
Yes, yes.
I just want to have a track of all the commands, as simple as that. Later I'll upload. You can also upload that list history to our this one G drive.
Okay.
Just to have a quick look and get a quick feel of them, Rahul, later.
Okay. Okay. This all commands, sir.
Please, yes.
Okay. Nginx rolling 2.
You can say load balance lb.yaml. Now ng-lb.yaml. So we know it is Nginx is the application, load balancer is what we are doing.
Yeah.
kubectl -f ng-lb.yaml. Okay. Okay, now go back to the AWS console and go to the EC2 instances. Sources and more precise. Okay, we see EKS. Just search for open in another tab. Look, sorry, yeah, look in ES2.
Yeah.
Two of them are coming up, and these two are the nodes. And in another, and do a new tab and just type in load balancer in the search. I mean.
Yes, I got.
Okay.
Maybe it is there only in EC2 section only. There is a load balance. Yeah, it is there.
Oh, there you go. Yeah. So that's going to be load balance, huh? Okay, and let's see, what are we looking at? Can you go into the security? One moment. Let's see. Yeah. There will be in description under security. In description, if you scroll down, there is. Have you maximized?
Description, security.
Under security, there's security group.
Yes.
Yeah, click on the security group. Okay, there are two of them. And let's see. Click on the first one. I'm just looking for the ports here.
All
Traffic is enabled. So it says all of them. I think it's allowing all of them. Click on the second one also. Go back.
This one was the second.
It looks like it is taking care of the. I thought.
Okay.
Security groups. Back to the load balancer, please. Scroll up, please. DNS name. Copy the DNS name. Before you do that, Rahul, go back to the tab where you have EC2 instances and copy the public IP or the public. You should have, okay. Just click on one of them and then copy the public IP or see if you can find the DNS name below. We can copy paste that and access that on the browser. Should be able to access the. So scroll down.
So that load balancer was created by the EKS cluster, right? Or it is?
Though, yeah, load was created by the EKS. True.
Okay.
You can start with the public IP and just paste. Okay. We should be able to access the engines.
All ports are open.
By default, I think it should go to 80, right? Okay.
Yes.
Can you just click on that and say 80, port 80? Okay, try the load balancer, please. Copy the DNS name of the load balancer. Yeah. Okay. So now what we should see is ideally, okay, now come back to the terminal and let's see, do a kubectl get service or do a kubectl get all. So let's see. So what we have is, it looks like the top two ones are the pods. Do we have two pods? Then we have the service slash Kubernetes service slash LB service. And for LB service, we have the external IP, but for the service Kubernetes, we do not have the external IP. So that is this one, the one below, if you notice, it says it is load balancer. On the top, it says it is cluster IP. Cluster IP is nothing but a load balancer, but it is only for the internal network. Load balancer for the external network, something to be kept in mind and something something to be aware of. Okay.
Yes.
It is giving us information of the deployment. Then it is giving us the last line is the information of the replicas. So we have pods, two services, one deployment and one replica set. Catching it, Rahul?
Yes.
We have created a load balancer. And ideally, how many replicas you want, how many of the instances is what we can easily configure it in our YAML file and you can do a deployment. Are you catching the point, Rahul? So
yes.
If we are able to configure the YAML configuration file properly, then no matter what application it is, whether it's a Java, .NET and things like that, we don't really care. All those things are they're getting deployed, and the load balance is being handled in a very simple way. Okay.
Yes.
Can you do a kubectl describe and say service LB kubectl describe service is LB hyphen service describe DESC. Okay, so if you notice here, load balancer ingress is generally nothing but our public DNS name. Ideally, you may not be able to access the browser and things. I mean, just in case you're not able to access the browser and things like that, you can do describe and get the load balancer ingress. That is the public DNS name. Are you catching it, Rahul?
Yes.
As simple as that. And let's see. Node port. So okay, I'll give you also another one, which is, let me upload this one. Node port, we're going to be doing a specific one here, app server and things like that. Okay. Back to the G drive, download the file node port service. File upload. Node port service.yaml. It's good. Could you refresh?
Yes.
Ah, there you go. And apply, please. When you look at this, how do you know what kind of an application you're actually launching, Rahul?
We are actually launching this in Nginx.
In other words, short and sweet, you're looking at the image key. The image,
Yes.
whether it's an Nginx or some other thing.
Yes.
It could be actually a Docker container on residing on a Docker on a public IP and things like that also. That is
Yes.
something important to be kept in mind. Okay.
Yes.
Okay. So ideally, what will happen is your developers or your development team, or maybe another ops team guy, your development team will create a container with the application, and they will share the network location or the AWS location with you. All you need to do is you need to refer to that location in that image.
Yes.
Okay. Apply. And so now, just go. The node port is also like a group of nodes is what it is. And if you look at the node port, let's see what we have here. So we are having a node port of 32,000. Port and target port is 80. We're calling it as an app service or an app server.
Yes.
And one deployment selector app server. Not much, not many replicas or anything like that. But let's see.
So this time it will run on this port 32,000.
That is right. So we need to verify that. Do a kubectl get cluster. We should get 2 of them. So what is clusters? We just did try it, didn't we? Can you just say get -help or something?
Or
Oh. Just look at your history. It'll be more easy. EKSCTL get cluster. Sorry about that. My bad. Yeah. EKSCTL is cluster level information. kubectl, it is a resource level information. Please do keep it in mind. Let's be aware of that. So EKS test is USEs 2. And what did we do? We just said, didn't you just you just applied it? Okay.
yes.
Okay, now say kubectl get services, get ports, or get all. What do we like? Space all.
Get all.
Yeah. So if you scroll up, we have service app, service/app service. Notice that is node port, and that is exposed at 32,000. And let's see. Under the names, those are the pod names. App server, that is our label. Deployment app server, and then replica set app server. So wherever you're seeing an app server, that is related to another app server. Front end is another app server. So that is how the label is using, because in a real world, you may be working with multiple teams and things like that. Everybody will have their own name. So that is the label is helping us in just distinguishing and identifying these components is what you can think of, Rahul.
Yeah.
Okay. So how many pods we have? We have app server 2, including app server, that is 3 pods. Then let's say wide is okay. And then what did we do here? This is the node port. For the load balancer, we have an external IP. Can you go back to instances?
Yes.
And I think you should see a third instance now.
Actually, we are deploying pods. Maybe you won't get any rows.
Pardon me?
We are deploying pods now. It will use same node. It will.
I gotcha. So let me see. Deployed service. I'm just trying to understand. For this one, we have added service, and that service on this port number is what we generally access. So service and the port number. What we need to do is we need the public IP. It didn't give the extra. Why don't you just copy that cluster IP 10.100.253.252 and plug in 32,000?
But it is showing that cluster is not ready still now. Pod is not ready this time.
Oh.
Pending.
Refresh. Just repeat one more time.
Still just pending.
Achha, still pending. We're using T2.micro. Yeah, I think only we have a limit of 2 of them, I think, on T2, T3.micro. So what we'll do, we've already. Output security. One moment, please. It is pending. Looks like there's a lot of work going on here. That's the load balance we created earlier. When we created the cluster, we have given the t3.micro. Can you just go back to the history and see, please? The node type.
It was T3.micro.
Micro. I think we should have used a slightly larger one there. I think we wouldn't run into this. One more time, can you do a get all? Just verify the status of the pod. Still pending, which means do one thing. Okay, I think we can delete this cluster, or we'll keep this cluster for a few minutes. Maybe you can delete it at the end of the session. Copy the same create cluster thing one more time, and instead of t3.micro, use m5.large. Node type is m5.large. Oh, give a different name. Say case test 2. Okay, and I think this was taking a few minutes, right, Rahul?
Yes.
Okay. Do you need a 5-minute break, Rahul?
Yes.
Okay, go ahead, take a 5-minute break and come back. I'll cover a little bit of theory after while this comes up.
Okay.
If you're back, let me know, Rahul.
Yes. The cluster is still waiting. So
Acha.
it will take 5 to 10.
Okay. And that's there. I should have it back. Take it on up. Can you try to open another Git bash into this one, please? Are you doing something, Rahul?
No, sir. You told me to just open this new table. What should I do now?
Log into the TKS.
Okay.
Okay, he's fine. Okay. Start with the EKSCTL Git cluster. And you're now in US East 1. Okay. So you have UKS East EKSCTL get all. Do a node group, get node group. Customer specific. Oh,
Maybe we need to specify the cluster name also.
Okay, just say cluster EKS test 2. No groups. Okay, still maybe working and things like that. So, could you do a get pods, please? kubectl get pods. Don't have. Screen is age 19 minutes minus 30 minutes. Notice, let me say from here. Pods say get pods -o kubectl get pods -o space wide wide WID. Yeah. And let's see, app server, we don't have any IP address yet. But for the rest of the two of them, the IP address are there. And it's still in pending because I think that one is the previous one. Okay. Could you want to one more time verify the status of the cluster? Back to your blue terminal. Still running. Cloud formation, okay. Okay. So again, just to keep our time a little productive, Rahul, I will share the screen and you let me know when the cluster is ready. I'll switch back to that one, okay?
Okay.
Share it. Okay. So different types of services. Oops. Can you see my screen, Rahul?
Yes, sir.
Okay, so platform as service, here the physical server is managed by the Azure or the cloud provider. Even the virtual machines are managed by the cloud provider. Some systems are automatically set up for us, example, database management system. In other words, if we were to just go ahead and take up something like a MySQL server or a Postgres SQL server, the server is managed and provided by the physical server, and the virtual machine is also being taken care of by the cloud provider. And we are directly working with an application such as database management system. That could be a MySQL or a SQL server is really. So what we are doing is we are saying the platform as service, they're doing as a platform as service. In other words, we're just working with the application. That could be a database application or any other kind of application. Let's come here. Okay, again, platform as service, a SQL database, any kind of SQL database allows you to host a database in the cloud. Here, the database is managed by the cloud provider, gives features such as automatic high availability, gives options such as automated backups. In other words, the cloud provider is taking care of all this platform. Together, all of those things are referred as a platform. So they are giving platform as a service is what we can say. Back to software as service. Here, in addition to the platform as service, the software is installed and managed for you. Okay, so in other words, let's say, come back here, back to platform as service, some systems, database, example, database manager, example of SQL. There also that is like a software only, but more of a power user. Whereas here, the Office 365, the Gmail, all these things are examples of the software as service, but we are not really the power users. We don't really write code. In a database management system, in the previous slide where we are saying platform as service, you're doing the development on the application product. So we're more of a power user. Here, we're just a normal user where we don't write the code in Gmail app or PowerPoint ad or other kinds of apps, but we just use them as it is. That is what is software as service. We're using the software. Platform means where we are also making some code changes and developing it is something to be kept in mind. Rahul, are you catching the difference, buddy?
Yes, sir.
Okay. So again, architecture, generally the traditional architecture is in a 3-tier architecture. We have the front end, we have the web server, database server. That is most commonly what you will see across and things like that at a fundamental level. So ideally what we would do, if we want to set up 3-tier architecture by the physical server, storage or licenses, database license, networking, what's happening, that's a lot of money. That is referred as a capital expenditure. Ideally what we do in a cloud world is you pay for the workforce to maintain the infrastructure, pay for running costs. Or in other words, more precisely, once you buy all those things, you also need to have some employees taking care of them. That is what pay for workforce refers to. Pay for running costs. In other words, this is recurring expenditure and it happens every 1 month. There's salaries and things like that. That is why it is referred as operating expenditure. So in the cloud world, we can practically have no capital expenditure because we are not buying any servers. Comes to the operating expenditure, we can only pay for the running cost. In other words, we don't have to permanently pay for whether the resources of servers are used or not. We only pay for what we use. We can terminate the resources whenever we want. So at the end of the session, we'll be terminating some resources just like that. We can terminate, and the advantage is we save the money. Okay, guys. So slightly deep on, going a little bit into it. So responsibilities between customer and the cloud. When we create a virtual machine, it is responsible for the uptime. It is create a virtual machine, the cloud provider is responsible for the uptime, maintenance, and various aspects such as cooling and security. We don't have to take care. So all that is saving the money. Customer is responsible for operating system level patching. So we may be working on Windows 10 or Linux, and generally some major security patches or important security patches, whether they're big or small, may needs to be applied. So we need to take care of it. So we're doing some work. That is why we're calling it as shared model. Customer is responsible for the applications and data hosted on the virtual machine. So all the data and the applications which are installed, we are taking the responsibility. They do not come under manage, and that is generally most of the times what happens, because we don't want our data and applications to be managed by external people. So we have our own set of team, the infrastructure team, and they take care of all these things, guys. Okay, so that's why, again, one more time, it's called a shared model. Region, short and sweet. It is just a group of zones. Have regions across the world which can be used to host resources. So there are some people in USA and they're using the application in other parts of the world, in Europe or maybe in India. It is better to maintain a copy of that server somewhere in Asia and somewhere in Europe, and they come into different regions. There are different geographic locations across the world. We can host resources in any one of the regions, and we can also have them replicated in other parts on a need-to basis whenever the customers are increasing in the other regions. Okay, so short and sweet, cloud computing is a group of regions. Region could be thought of as a group of zones. And
the cluster is ready.
Okay, sorry. Go ahead, buddy. Okay. Now, EKS test 2, right? Open the cat the YAML file. The one we just node port, yeah, node group. Are we referring anywhere? The name of the cluster here, deploy, web server container, API version apps v1. Scroll up, please. So just do a grep for EKS test. Cat it and grep it, so that in case our eyes don't catch it.
EKS?
EKS, that's it, just EKS. Okay, nothing is there. EKS CTL get cluster. So we have test 1 and test 2, okay. And let's say ls-a. So we have a .cube here, .ssh, .cubectl. ls-a .cube. You can do ls-r .cube. And cat the config file there. Sorry about that, Rahul. A little bit of power cuts going on at my end. So sorry about that.
Okay.
We're looking at the queue config. So there is a V1 and cluster. This is the key. Scroll down, please. So that is the server information, and we are in use EASE2 and EKS test. This is the EKS test, and there is EKS test 2 also. Thank you. So we have two clusters information. Let me see. Try doing the apply on m2.large, I think, or m5.large, I think, the earlier one. Maybe give me kubectl. Just
This was the file which we need to deploy. But how we can specify that on which cluster should it get deployed?
okay. I'm back, Rahul. Sorry about that.
Yeah. Actually, how can we specify on which cluster should get deployed? Like we are doing this kubectl apply.
Rahul, can you hear me?
Yes, sir. Hello, am I audible?
Rahul, can you hear me?
Yes, sir. You are audible.
Oh, okay. Sorry.
Okay. Is I am audible?
Yeah. You're on. And
Yes. Sir. So if I do apply, how can it will know on which cluster it will get applied?
gotcha. Apply, and I think shortcut is we want to apply it. What I'm thinking is cluster hyphen cluster name. Apply -f cluster -name EKS test 2. Okay. Yeah, just look for apply help. Sorry about that. And let's see if they have given us an option for specifying cluster. Pro. I know by default it goes to that .config file and picks it up from there. Yeah? But let's see. Just we should find. Okay. It's just one. Okay, so ideally what we can do is we can probably do it from another server as a shortcut, but let's see. Okay. Go back to history, please. You did a create cluster on EKS test 2. And you specified the thing here. That's because we wanted the ports. I don't think we need the cluster EKS test anymore. Can you delete the cluster?
Okay.
EKS, delete cluster, name EKS test. Region is US East. Okay, try that. And unknown resource type EKS test.
Delete cluster, then we should. Yeah, it is deleted.
Okay. Don't think it should take too long.
Maybe we first need to delete those ports. It's failing.
So is that an error or a warning?
Yeah, it is warning. Yes.
Unretrievable error. Ideally, we should not take care of anything. I mean, it should only take care because that is what is the very idea of the manage thing. You just said delete.
Yes, yes, right.
You said you don't have the Google Cloud credentials, right, Rahul?
Yes, yes, we don't.
See, can I do this? Okay, while that is coming up, just open another browser and go to console.cloud.google.com. Yeah. And let's say, go ahead and say get started for free. There are a few initial steps if we look at this one, maybe. What is this describes? You can just say other or something like that. Personal, yeah, just say personal. Have to agree. Okay, just agree on all of them. Click on continue. Rahul Gupta, okay. I mean, do you have any credit card or anything like that, Rahul?
Yes, yes.
Okay, so what it is going to do is it's just going to deposit 2 rupees. It will not really do anything. And again, it will debit and credit just to verify you're a genuine user or not. Is that okay? Is that going to be okay with you?
Yes, okay.
And stop sharing. Just enter your credit card number. Stop the sharing. Yeah. And complete that step, please.
Yes.
Are you having any issue, Rahul?
No, sir. I was actually searching for my credit card. That's why.
Oh, okay, okay.
Sir, it is not able to verify my credit card. I'm facing some issues.
It's not able to verify your credit card, huh?
Yes, yes.
Okay.
I'm trying again last time.
Okay.
Yes, sir, I'm able to hear this.
Okay.
Sorry.
I'm also trying to create here, but give me. This one. Let's see. Okay, so you're back in. Oh, you can just close this one or just say done if it is allowing you. Just choose something. Let's. You can say skip for now. Okay. Well, the first thing we'll do is go to billing. And let's say, give it a moment. Here's the current month. So you have 0. And so what we'll do is at the end of the day, before we complete, we'll just make sure we're not being billed and things like that. So most of the time we'll be using the free servers only. So we shouldn't be getting billed. And now what we'll do is in the search, where you have search products, resources, just type in projects on the top here. Projects. And let's say, create a project. have 11 projects remaining here. Request entries. Okay, some new things coming up here. And okay, my project 8820, no organization. Click on browse. So, okay, we can cancel this one. Just say create. And now what you need to do is click on go to project settings. On the right hand side, scroll up. It's actually the first this one, yeah, below. So the project ID is to access transparency. What we'll do is there is somewhere we need to enable billing for these projects. Otherwise, okay. On the right hand side on top, there is a cloud shell. Click on that one, the greater than by the right hand side of the search box. Cloud shell, yeah. Activate the cloud shell. Yeah, continue. And let's say it's still connecting, okay? Yeah, open a new window. Click on that so that we don't have to struggle to see it. Okay, so there it is. That is going to be a console window. You can just bump up the size of the text. There should be on the top right hand side. There is there you go. Okay, yeah. Text size, say medium or large. Okay.
Is it okay or should I increase more?
Pardon me?
Is this size okay or should I increase more?
Yeah, that's good. That's good. And let's see, come here from here. This. So this is version 2. So let's say come here. Okay, now what I want to do is there is one step I wanted to do. Just give me one moment here. We have created the project. Just type in G Cloud compute regions, G Cloud compute space regions, and enter. Enter. List Google Computer. Try list, please. After compute regions, list. No. I mean G Cloud compute regions space list. Authorize. Not enabled on project. Would you like to enable and retry? So just say yes. Can you also simultaneously go back and check on status of our cluster, Rahul? One more time, do a cat on the .config file. Let's verify it's now has a reference of only cluster 2, EKTest2. No, .config file. So it should be under .cube folder /config. And we do have EKTest2. And scroll up, please. Make sure it doesn't have a references of EKTest1. Looks good. You got it, Rahul?
Yes, yes.
So basically, as we deleted it, removed the references from the .config file. And
Yes.
now we try to do an apply of the node port here. Apply -f node port. Yeah. And go back to AWS instances, console. And where are we? We're doing node port. So we'll come back here and see that. This logging. Where did this go? Let's see, cloud. P3, okay. So get ports. So now just in the terminal, can you check and see if we have any ports coming up here? And yeah. Get ports -o space white. So if you notice the node, copy the IP address of that one. Yeah, where it says IP1. Yeah, copy that IP address and paste it in a browser. Say IP. Yeah, you can copy that one and try to access the 32,000, I think is what we have given. Still waiting. While you're waiting, go back to the EC2. Yeah, EC2 and security groups under EC2. File large, okay. Security groups. Under EC2. And all the ports are here. Let's create a new security group. We'll call this as NP security group, like a node port security group. Yeah, okay, empty. I meant, okay, NP, N for new, P for Peter, NP, node port. Node port, buddy. N for node.
NP.
So that it's easy for us to remember. And in the VPC, EKS test 2, select that one. And let's see. We want 32,000 port, right?
Yes.
So yeah.
That's correct.
Yeah, that should be good. Tags is okay. Create security group.
Now should I attach this to both the view?
You have created that right now. Go back to the instance. Yeah. And go to the instance state and security group, or I think somewhere you can do security. Yeah, actions, networking, change security group.
Yes. And
Okay. And
we have created this MPS.
security group. You have added NP, SG, and let's see.
So,
I mean, so do a search, click on that one more time where you have select security group. Just see if it's bringing up. Okay, 1 minute. So the first one is NPSG and EKS test 2 cluster control panel. 1 moment. It's not giving the description. Or is it not giving the description? It generally says sign security. Yes, select that one also, please. Which is one on top of that.
okay.
Yeah, that one. And add it. Security group. So, is there anything else under EKS test 2 when you search? You have a default, which is okay. EKS test is gone, okay. EKS test 2 is there, and we already have given. This is the control plane security group.
Yes.
Do I need a control plane? I don't think I need a control plane, but let's go ahead and save it.
Okay.
Save it, yes.
Should I do same with the second one also?
No. Oh, right. 2 of them, right?
Yeah, we have to.
I think it's automatically getting added on the other one, isn't it?
Also, it is.
Okay.
Actually, for this one, it is showing only one, and for the first one, it is showing.
Oh, okay. Are you right now doing it?
Okay. Should I do?
What I thought was, if you select the one that you have already given, look at the public IP address and try to access the 32,000 port now.
Okay.
Copy it. You understood that?
Yes. Yes.
Now try to copy the public IP of the other M5.large. And just
That is to instance.
yeah, the one where we had only 2 of them. Contains malware. Okay. Go to details. Set this on safe site. Yeah. Click on visit. Okay, we're not able to access. Maybe we need to, I mean, short and sweet, we need to probably be able to access that one, which is at the security group is what it is. But
Yes.
let's see. If you go back to a G drive, no, just do an LS on your terminal. Do you have that the first rolling or something like that? So we have an LB's load balancer node port and NG. Can you do a cat on rolling? So that is a metadata. You have 3 replicas. Scroll down Nginx 1.16 and scroll down, please. Scroll up rolling update. Okay. So this is test deploy. Can you also try to apply this one, kube apply, kubectl apply?
Okay.
Yeah. And then do a kubectl get all. And let's see, now if you notice, one of the things I wanted to tell you was, if you notice that there are 4 pods which are running here.
Yes.
3 of them are test deploy, one of them is app server. App server is coming from the previous one, but right now we have 3 of them, and notice all of them are in status running because we are using m5.large. If you use
Yes.
a less than m5.large, you would have a limit of only 2 or 3, something to be kept in mind, okay? So just in case you troubleshooting issues and things like that, somebody is using not using m5.large. I think m5.large you can run up to 9 or 10 of them. There is a limit, but something to be kept in mind.
Yes. Okay.
Now what I want to do is, let's say we'll try to manually kill one of them, which is, okay, how about you do this one? Type in kubectl scale, kubectl space scale, space hyphen replicas, space 5, space, I think what is the name of the deployment.apps / test deploy. Copy that one, yeah. Okay, yeah. Run it. Now do a get all. And let's see, now notice the test deploys have increased to 5.
Yeah.
So in other words, this is an imperative way. This is where we are doing a manual. We're kind of doing it manually. When you use a YAML file, that is called a declarative way. This is called an imperative way.
Okay.
If you want, you can also scale it up, scale it down, and things like that.
Okay.
Okay, and if you notice under the test deploy, notice under the last one, replica set, there are 5 desired, current is 5, ready is 5, and age is 101 seconds. These are some of the things that you generally keep track of. You're looking for since when they're running, how many are desired, how many of them are current and ready, because some of the times if the desired or the current is the same, not the same number, then they're out of sync. Some of them are down, some of the containers pods are down, and things like that.
Okay. Yes.
Okay. And let's say, okay, how about we'll try another one. Type in kubectl space create space deployment space my dep. Just say my dep. It's like my hyphen dep space hyphen image equals to Nginx 1.16. No space. Nginx 1.16. Cool. Yeah, enter. And now do a get all. That's it, my dear. Okay, so that is what we're doing is now this is an imperative way. We did not use a configuration file. We manually deployed the deployment set manually without using a configuration file. Catching it?
Yes. So if we specify in that configuration file, it is declarative, and if we run this command, it is imperative.
Yes. In other words, most of the times when you're troubleshooting somebody, and let's say there's a development team saying that, hey, we need to have 5 or 10 of them up and running, but we have only 4 of them up and running, and you need a quick way where you want to bring up one of them. If it is container level, you can increase the number of replicas, or if it is a deployment level, then you can go ahead and create the deployment like this. Catching it?
Okay, yes.
So ideally what will happen is, for now, we will have multiple deployments running. We can also dig deep into it, but for the time being, we run it. Then later on, while this is running, because the load is up and things like that, we are manually bringing it up. And later on, they will look at alternate ways of doing it declaratively rather than imperatively.
Okay.
And another quick thing we will also do is we'll do a quick pod test here. This will take time. Just do a kubectl get ns, get space ns, ns for namespace. Kubectl. Okay, there's something called kube system. So next one, kubectl get pods. -n cube system. Copy that cube system, the last one. These are all the different namespaces. The namespaces are nothing but a group of components logically tied to each other, as simple as that. So just go. So AWS node, core DNS, proxy. These are at system level. Kubernetes system level. These are the components at a system level is one way to think of that.
Yes.
Okay. I think the deployment, I think we have done it. We don't need to do it again. But one last thing we could do is go back to do a cat on the ng-rolling. Rolling.yaml. And let's see, replicas are 3. Edit the file, change the replicas to, let's say, 20. Now, edit the file, change the replicas to 20.
Yeah, I did.
Okay, apply it, run it. Get all. Cool, all of them are running. Okay, so in other words, I was actually, I wanted to show you only 10 or 9 of them would be running. The rest of them would be pending, but it looks like M5 large has a much higher limit. And okay, 20 out of 20, all of them. Take a look at that. What is that? 20 by 20 is ready. 20 of them are ready.
Yeah.
The second one, test deploy, I think is what it is. So 20 of them are ready. Okay, I just wanted to quickly show you. Okay, I will save a little bit of it for tomorrow. on this one. I come back here and go back to your Google Cloud Shell, but you're getting an idea, right, Rahul?
Yes, we can run more than 20 containers.
Yeah. And if we stop our instances in AWS, are we still getting built? Do you know?
No, but it is very minimal if you stop the instance.
If we stop it, what I'm thinking is instead of deleting it, because if we try to start them again, no, I think we should be okay. Go ahead and delete the cluster just so that, because we're using m5.large and things like that, right? Delete the cluster. I think it is EKSCTL delete cluster. First to get clusters.
Okay.
EKSCTL get cluster. EKS just to delete the cluster. Okay. So that is about that one. And while that is going on, let's come back here. Back to the Google Cloud Shell Buddy.
Yeah.
So these are the different regions, just like in AWS. Here also we have regions, zones, and things like that. Cloud is a group of regions. Region is a group of zones. Zones can be thought of as a group of data centers. Is what it is. Makes sense,
Yes.
right? Okay.
Yes.
And let's see what else we have. A bit of theory here. Let's save the theory for tomorrow. Just an instance. And go back to the previous tab. Search what's that? Okay, that's the previous one. Have you created the project?
Yes, I have created one project.
Click on that. Are these that you created some other time, or these are the template?
These are I have done this some Android projects. Maybe they are showing also.
Oh, okay. That's cool. Yeah, you don't need to select those things then. This is the one we just created, I think, right?
Yes.
And okay. Okay, just for sake of the discipline, instances on the top. Search project
Like,
instance. Like an instance. Yeah, ESTA. Yeah, instances. Yeah. VM instances. There's one of them called VM instances.
VM.
So this is like our instances in the AWS. Since my what's that? Yeah, enable. Okay. Tomorrow we'll try to create an instance. Today we'll just see the steps, Rahul.
Okay.
So that we are not charged and billed and things like that. It'll be
Okay.
This is also free one only, but for the sake of discipline, I just want to show it to you, and we'll wrap it up for today. So I'll be mixing a little bit of tomorrow. I'm planning to cover a logging in Kubernetes. That is most of the time generally what you'd be interested in knowing. apart from these tips and tricks that we have looked at today. It's
Yes.
a important one. We'll spend a little time on that. Then I'll move on to a little bit of GCP. We'll try to spend some time creating some instances, databases, and things like that, buddy.
Okay. Logging into Kubernetes means will we create that dashboard and then?
Yeah. So let me see. I think first I'll cover the Kubernetes dashboard, then I'll cover the Fluentd and the Elasticsearch Kibana.
Okay. Okay. So will this Elasticsearch Kibana is managed service by AWS or we will install on the server?
It is managed, buddy.
Okay.
Okay, so just say go ahead and create an instance. Instance 1 is okay. Las Vegas, I think you can select the region somewhere close to India. Just check out.
Maybe
Mumbai is okay. You guys are located in Mumbai, right?
right. Yes.
Good. Okay. General purpose C2. The series select N1. Scroll down. Powered by Intel. Okay. And here in machine type, look for f3.micro. Those are the free ones. That's it. Huh? No. Select series N2. Is it f1.micro? And N2 is something like f3.micro. I thought, I mean, we can select f1.micro, but just for sake of, I remember I was working with f3.micro. First generation, okay. Go. Hold back. Yeah. So have you selected N2 and look for f3.micro? Yeah.
F3 is also not there.
Strange.
Maybe our region is.
Oh, gotcha. Gotcha. Understand. So
should I change the region?
No, that's okay. Keep the region same. Just select f1 dot. We'll go back to see if there is any f1 dot micro here in machine.
It was there in
okay.
Yeah, there is f1 dot micro.
Okay, you can select that. And let's say display device confidential is okay. Deploy container, boot disk. Change the boot disk. Operating system, choose, let's say Ubuntu. Yeah. And let's see, version, select 18.04 is good, but just expand the drop down. We also have 20. LTS, minimum. No, don't select 20. That's the latest and the greatest. We'll run into unnecessary, just to be on safe side. 18.04 is good, but okay, click on advanced configuration. So deletion, Google managed encryption, snapshot schedule. Scroll down, you can say select. And image we have done. Compute engine default is okay. Access scope, I think allow default is okay. Then we have allow HTTP traffic that will allow us to access the thing. So now what we'll do, let's go ahead and create it. It's okay. We can get rid of that one. Since it's free tier also, it wouldn't matter that much. Still running. Okay. Oh, event set. What is that? South 1C does not have enough resources available to fulfill the request.
Yes.
Oh, okay. Okay, never mind. No, what we'll do is we'll not create it. Just have an eye on it. Make sure in the later part of the day it's not created or something like that, Rahul. A little bit of work for you. What we'll do is we'll try to create, just remember zone. We'll try to create the instance in a different zone tomorrow and try to play around. Okay?
Okay.
Any questions before I wrap up today, buddy?
No, sir.
Okay.
So, sir, for what we will use that ELK or Kibana for monitoring purpose? For what monitoring?
For logging, generally what is happening is all the worker nodes in the control plane, they do the logging in their hard drives. So if on, we will not be able to access the log files and things like that. So that's where EFK comes in, where it's like a cloud logging. So even if the servers go down, most of the times the workers may go down. And in such case, the application logs is what we'll be looking into, digging into, and trying to troubleshoot and work with others and pass it on to others and things like that. So if you log it into EFK, Elasticsearch and things like that, then they are never down. They have their own backups and things like that, and a lot more kind of analysis analytics can be done on them that we could ideally not do on a single node or a single worker. Where the aggregation of all these log files will become a challenge. There are a few more challenges like that. All those things will no longer be a challenge if we log on to use the tools such as EFK together.
Okay, so we will use that for application for monitoring API.
True, application logging primarily. Master doesn't really go down that often, but most of the times it's the workers which are having troubles, and many times we need to aggregate the logs from multiple workers. And production or a real-time environment, nobody will have that much time logging into SSHing into each one. So they try to aggregate. This will put everything together at one place.
Okay, so means we will use it for monitoring this Kubernetes cluster. Okay.
True. Yeah, true.
Okay. I got it.
Yeah. Okay, buddy.
Okay. And for what purpose we will use that Fluent?
Fluent is for logging. Kibana is a dashboard. Elasticsearch is where it's the cloud which will maintain all the log files, and you can search on the cloud.
Okay.
Discuss about that tomorrow. Cool.
Okay.
Okay. So Moin, Humera, Shrishel, Shraddha, Sumit, are you guys doing okay, guys? Okay. If you don't have any questions, we'll stop it here. You can stop the sharing, buddy.
Okay.
And we'll continue the journey from tomorrow and go from there, guys.
Okay.
Thank you, Rahul. Thank you, Nitish. In case you need anything urgent, things like that, just WhatsApp me, Rahul.
Yes, sir.
Just let the team know that you have my contact information and they can just feel free to get in touch with me.
Yes, sir. Okay, sir. Thank you.
Thank you, guys. You guys take care. Stay safe and keep learning. Thank you and bye for now.
Thank you, sir.